So take everyone, here I have a pendulum, okay? And the time it takes to go from here, there, and back again is called one cycle, okay? We're gonna call that one cycle. So how do you think we can change the length of one cycle? What can we change about a pendulum that's gonna change the cycle?
You get a different weight. You could make it heavier.
The mass, you can change the mass.
Make the weight nice and big.
Okay, so let's try changing the mass. Okay, so here I have a really light mass, right? So I'm going to take it here, I'm going to drop it. Okay, so you got that time, right? Ready? Mm-hmm. So you see how long that takes? Okay, so now I have a heavier mass, I'm going to drop it from the same angle. Same way, ready? What do you notice about the time that it takes to do one cycle?
It's the same.
Okay, so what do you notice about that?
Look about the same.
Look about the same, right? So why do you think that is? Do you have any idea why the mass does not affect the time it takes to do one cycle?
Maybe the acceleration and deceleration is the same?
You know when you have two objects and they're different masses, and you drop them from the same height, they're gonna hit the ground at the same time, right? Well, it's the same thing happening here. How hard this is pulling down on the rope doesn't actually affect how fast it's moving. So now, is there anything else that you might think that might change, like how long it takes to do one cycle?
The angle or the height.
Maybe the height.
The height you drop it at, okay. How could I drop it differently to change the cycle, the length of the cycle? Drop from a higher angle, right?
The angle that you drop it from.
Drop from super high. Super high, just like Tyrone.
Ready? So I'm going to drop from a very steep angle here, right? Ready? I'm going to do shorter. What do you notice about the time that it takes? Not how fast it's moving, but about the time it takes to go from here and back again. Versus when it's a higher angle here and a lower angle here.
It doesn't. It's about the same.
It was still actually almost the same.
It was almost the same, right? So why do you think that is? So do you have any idea why that might be? Yes, or maybe so? No? One we can guess?
Because it's the same weight and everything.
I don't know.
Because if you drop it from a higher angle, then it's faster, but the distance is greater. But like if you drop from a shorter one, like it's slower, but the distance is.
Yeah, that's exactly it. So the reason why the angle doesn't actually affect the time it takes to do one cycle is because when you drop it around here, it moves a lot quicker, right? At the start, and it accelerates a lot quicker because it's on a steeper of an angle, right? And for the same reason, it decelerates quicker over there too, right? But when you drop it from over here, it only has a very shallow slope, right? It's not a very steep slope to move from here and back again, right? So think of it as a skateboarder on a half pipe, right? When he's at the top of the half pipe, he moves a lot quicker, right? He's going to decelerate a lot quicker at the top. When it's very shallow on the edge, or it's not very steep, when he's at the bottom of the half pipe, like right here, he's not going to move quite as quickly, right?
Yeah.
So even though they move at different speeds, the one higher up has to move farther, right? Than the one shorter down only has a small distance to move. So if this didn't change how long it takes to do one cycle, what else might?
I don't know, the length of the string.
The length of the string. What could I change about it, do you think?
The length of the string.
The length of the string.
Make the string nice and big.
Get a shorter string.
Get a short string, okay. So let's see. So I'm going to take this string, I'm going to bunch it up a little more. Okay. So now I have a very short string, right? Mm-hmm. So if I take it here, I'm going to drop it. See how quick that was, right? Mm-hmm. Now I want to make it longer. So now when I drop this, I'm going to drop it like that, okay? What do you notice about the time that it takes to go from here and back again?
When it's shorter, it's quicker.
It's a lot quicker, right?
They were not the same.
They're not the same. So which one was longer?
This one.
This one was longer. It's a longer rope, okay? So why do you think that makes it quicker to do this than when you have a longer length of rope?
Maybe because, I don't know, like the weight is like balanced out differently.
Maybe the length causes it to get restricted at some point, and then if it's a longer length, then it'll only get there and you start having the pulling force, but if it's a starter, then maybe it'll, start having the force sooner and it will decelerate sooner.
When it has a longer length here, right, it's going to take the distance that it has to move from here, there, and back again. It's a lot bigger distance, right?
Okay.
Whereas when you have a shorter, if you drew a line here, it'd just be a very small distance that has to travel. It has a shorter distance to cover when it's shorter, right? So that means that the time it takes to do one cycle is a lot shorter.
Okay.
Okay? That's it.
Took me a while to think that.
Stop screaming! No!
Don't be here if you're gonna laugh! Except for like that, maybe. Shut up.
Josh, how do you spell Caillou? How do you spell Caillou?
It's
C-A-I-L-L-O-U, bro.
Yeah.
Get 2 L's.
I know how to spell Caillou.